Unit 3, lesson number 1, we're looking back at law of sines. Now, we see that we have angle A, and angle or side C. Once I have the two matching up pieces, and again I don't have two angles, I know this is going to be a side angle problem, which means the ambiguous case. Yes, okay. So, with the ambiguous case, I'm always going to draw my angle that I'm given right here. So this is 57 degrees. Okay. The side opposite of it, I'm going to go ahead and draw that in there. The side opposite is going to be 15 feet. And then this other side value, the extra side, I'm going to always put it right here. Okay, so I have 20 feet there. So this is my angle A. That makes this my C because my side C is across from it. And this is angle B. Okay. Now, I need to go ahead and find my height. Okay, and the height, again, is always going to be equal to, it's the sine of that angle. Okay, sine of that angle. I'm sorry, is this sine? Yes, I'm sorry. It's the sine of this is equal to the height over this side. So it's going to be h over 20. I'm going to multiply both sides by 20 to get h equals to that number. That number I will type into my calculator and get 20 times the sine of 457 degrees is actually going to be equal to approximately 16.77. I'm going to go ahead and leave it like that for now. Now, let's go ahead and talk about this actual situation. If my height is equal to 16, technically, I'm going to go ahead and cross that out. H is equal to approximately 17. That means this in here is 17 feet. Okay. Let's talk about this 15 feet. If the height is 17 feet, the side that is slanted is supposed to be longer than it. So in theory, this is what I'm actually seeing on this triangle. Okay, I see 17 here, I see 57 degrees there, I see 20 there, okay, and my 15 is coming down, and then it stops. And it's just going to swing back and forth. Right here will be the closest it's going to get. Okay, again, right there is where closest it's going to get. But it's going to be 2 feet short. It's going to fall 2 feet short of where I really want it to be if this is 15 feet. Okay, so this whole situation right here with this triangle, I hope you're thinking, not possible. Okay, now let's go ahead and refer to our actual ambiguous case in my notes. Well, first of all, okay, my A is acute. Okay, if my A is an acute angle, that means that I'm going to look at the side opposite and compare it to all the possible situations. The side opposite is 15. It is less than the height. Okay, it's less than the height. A is less than the height. The side opposite is less than the height. No possible triangle. My answer for this problem is no triangle. Okay, so that finishes 7b. Let's talk about 8a. Okay, so for 8a, we have a radio antenna 85 feet high is located on the top of an office building. Okay, so I have an office building, I have a radio antenna. Okay, at a distance AD from the base of the building. Okay, the angle of elevation to the top of the antenna is 26. So I've got building, antenna, angle of elevation, okay, is 26 degrees. Okay, this is the angle of elevation to the bottom of the antenna, so I'm going to have another angle of elevation to there. And that's going to be 18 degrees. Oh, sorry, 16, not 18, 16 degrees. Okay, again, very carefully drawing these pictures out. The pictures are hard to see in these videos, so I have the original one right here, okay, and then I have my secondary statement right here. The red angle, okay, is supposed to be 16 degrees. This whole angle here, the big one, okay, going up to the top of the antenna is 26 degrees. Now, this is a radio antenna 85 feet high. Is located on the top of an office building. Okay, that means that the antenna itself is 85 feet. Okay, is there any other missing information from this? No. What's it asking? Find the height. Okay, that's what it's asking us to do. It's asking us to find this H value. What is the height of this building? Okay, well, this is kind of nice because this is obviously going to be a 90-degree angle. This up here is going to be a 90-degree angle. Okay, so in some way we can compare these particular things in a way very, very nicely. Okay, now the last piece we need to worry about is this. Okay, I could in some way do this without using law of sines at all. Okay, you'll notice if this is 26, then this 90-degree angle will tack onto the 26 and give me 116. This angle up here can be given to me. Okay, and I can just go ahead and use trig functions. I mean, in theory, I'm pretty... Oh wait, I don't have this side. And I don't have this side down here. So I really actually can't use trig functions only because I'm missing these sides here. Okay? But if I'm careful, again, if I'm careful, what I can do is I can say, well, I know 85 plus the height is the whole height. Okay, is the whole side opposite this. Okay. I also do know that I can say 16 will compare to that height in some way. And maybe I should just go ahead and say heck with it and try and compare these two things using law of sines in some way. Okay? So, let's go ahead and do that. I know that this angle here, okay, the angle that's inside here, which is actually going to be an angle of 10 degrees, okay, is actually going to allow me to find out or relate this 85 feet in some way to everything else. Okay? So, what I'm going to have here is I know that 10 degrees, so the sine of 10 degrees, okay, this angle here, is comparative to 85. I think with that, I might actually be able to find this extra side here. Okay? I might actually be able, actually, I'm sorry, this isn't 90 degrees. This right here is not 90 degrees. That's just some angle. Okay? With that, I could potentially find this side if I knew this angle over here. Okay, I could do the same thing with this side if I knew this angle over here. Okay, but I'm not sure I know any of those sides. Well, let's go ahead and redraw this triangle. I think this thing's getting very, very convoluted. There's a lot of stuff going on here, and it's hard for me to see what I'm doing. Okay. I have this total thing here is 26 degrees. This one is 10. Okay. This one here is 16. I know this is 90. I know this is 85 feet. This is what I'm looking for. That's my so-called X. Ooh, wait a second. If I'm looking at this outside of the picture, I can find this angle right here. If this is 16 and this is 90, 90 plus the 16 will be 106. This angle measure here that's left is going to be 74. Okay. I can find this angle up here then too, because 74, 180 minus 74 should give me that angle there. So 180 minus 74 would actually give me 106. Which is logically true. Okay. If I have 106 plus 10, what's that going to give me for this angle up here? Well, that's going to be 116, and therefore this is going to be a 64. Okay. I actually solved all of the angles in this triangle problem. Now, I don't know if that's going to get me anywhere, but I think that's a good start. Okay. Remembering, I want to find out what this side right here is. Okay. I want to find out what that side is right there. Well, I can compare that 85 to sine of 10 now with finding this opposite side. So let me go ahead and do that. Okay. I say 85 feet compares to the sine of 10 degrees. 85 feet compares to the opposite angle. And I want to find this side over here. Okay. If I can find this side, then I can say this whole side compared to this whole side in some sort of sine problem with the right angle. Okay. This should be equal to, well, I'm going to have sine of 106 degrees. Again, the angle opposite that side. And I'm going to call this side x. Okay, so x. Let me solve for x. X is going to be equal to, doing some calculator work and some rounding, I have 85 times the sine of 106 divided by the sine of 10. And that gives me a value of 470, okay, 0.5. That's a very, very large number, okay? But it's not going to be anything terrible for us to actually utilize. This is not the way your textbook does it, just so you know, okay? I took a quick glimpse, and this is not the way that your textbook does it. It doesn't matter how your textbook does it, as long as you get a value that is relatively appropriate. Okay, so the next thing that I'm going to do is this, and watch very carefully what I do. Okay, if I know what this side is, and I know that this whole side is 85 plus h, couldn't I do the sine of 26 is equal to those two things added together divided by this? So that means that I have the sine of 26 degrees is supposed to be equal to, now I'm going to very carefully write this out without having to use 470 divided 0.5. I don't like that number. It's an approximation. I want to get exact as close as possible. So this thing, x equals to this 85 times this thing divided by this thing, is what I'm going to use. Sine of 26 is equal to the opposite, 85 plus h, okay, divided by that x value, divided by, I'm going to go ahead and write it all in parentheses, 85 times the sine of 106 divided by the sine of 10 degrees. I'm going to go ahead and multiply both sides by this thing, multiplying both sides by that thing, and then subtract 85. Okay, so that's going to give me the sine of 26 degrees times 85 times 1 over sine of 10 degrees times the sine of 106 degrees. This thing minus 85 is supposed to be equal to h. Okay, I'm going to go ahead and type that into my calculator very carefully. Okay, I'm going to use the previous thing that I already had right there. I'm going to multiply that thing by the sine of 26 degrees. Let me check to make sure it's doing it right. Yep. And I'm going to subtract 85 from it. And it looks like it's going to give me something approximately close to 121.268 feet, which is, because it asks, find the height of the building and it doesn't tell us what to round to, I'm going to look back at the building and I'm going to say all of my length measurements are in terms of feet. And all of my length measurements are whole numbers. So I'm going to round it to the nearest whole number. The height of the building, h, is 121 feet. Okay? Again, very careful with these problems. What I would suggest, anytime you're given a word problem like this, draw the picture very carefully, and then redraw just the mathematical picture. Solve the angles if you can, and then start working with the heights and the sides. There's not just one way to do these problems. This is the way that I saw of doing it. There are other ways. Okay, so that completes lesson 19, unit 3, section number 1.